Hey guys, welcome to the notes for geometric sequences. We are in Unit 2. It is actually the last part of Unit 2 that we'll talk about. Our essential question is, how do I find the common ratio? All right, so our vocabulary is geometric sequence and common ratio. So previous to this, we learned about arithmetic sequences. And arithmetic sequences are sequences where the change is you're either adding or you're subtracting numbers to get from term to term. And that number that you were adding or subtracting was called the common difference. Here we have geometric sequences, and instead of a common difference, we have common ratios. So a geometric sequence is a sequence whose change is denoted by multiplication only. So just using multiplication, that is the only way that I can figure out if it's geometric or not. There's no such thing as dividing, okay? Then the common ratio is the number being multiplied from term to term. Okay, so as I'm getting from term to term, I'm multiplying something. Now, the recursive formula for this is pretty much the same thing as it was for arithmetic, except instead of a plus d value, we now have a times r value. So let's talk about what a of n means. A of n is going to be the term we are looking for, or the term I am looking for, whatever you'd like to say. So this is our desired term. So again, as a review, a of 5 means I'm looking for the fifth term. A of 1 means I'm looking for the first term, okay? Now, a of n minus 1 means the previous term, so whatever term was previous to it, okay? So whatever your last number was. And then the times r is going to be your common ratio. It's the number that you're multiplying to get from term to term. Now, before we get into examples, I want to go over something really briefly with you. And I'm going to do it over here for a second. So I'm going to give you an example, okay? My example is going to be 4, 2, 1, 1/2, 1/4, comma, dot, dot, dot. Okay, now, as you're looking at this, I want you to look at what's happening as you get from number to number, okay? Now, I want you to look. How are you getting from number to number? Well, you're like, well, I think it's dividing by 2 each time, because 4 divided by 2 is 2. 2 divided by 2 is 1. 1 divided by 2 is 1/2. So what's happening here? We're dividing by 2. Now, like I said earlier with geometric sequences, there's no such thing. It's multiplication only. So yes, it's dividing by 2, but we also know that to be the same thing as multiplying by 1/2. Okay? If I take 4 and multiply it by 1/2 in my calculator, I'm going to get positive 2. Okay? So if you're dividing by 2, you're multiplying by 1/2. If you're dividing by 3, you're multiplying by 1/3. If you're dividing by 4, you're multiplying by 1/4. If you're dividing by 8, you're multiplying by 1/8. So it's good that you can recognize that it's dividing by something, which is great, except we don't divide with geometric sequences, we multiply. So you can't say I'm dividing by 2, you have to say I'm multiplying by 1/2. You can't say dividing by 5, you have to say you're multiplying by 1/5. So I'll go ahead and just kind of leave that there. Okay, so determine if the following are geometric. If they are, find the recursive formula and the next 3 terms. Okay, so starting with number 1, I need to figure out if this is geometric. Remember, geometric sequences is when you add or subtract something from side to side, or to get from term to term. So as I go from 5 to 15, well, how would I get from 5 to 15? I have to think in the mind of multiplication. I'm like, well, I could multiply by 3. Okay, let's go ahead and do times 3. Well, can I do that as well? So let's try. If we do 15 times 3 in a calculator, I get 45. If I do 45 times 3 in a calculator, I get 135. So there's the same number being multiplied from term to term. So that's going to tell me that yes, this is a geometric sequence. And my common ratio here is positive 3 because I am multiplying 3 to get from term to term. Okay, so let's go ahead and write our formula here. Well, our formula always starts the same. A of n equals A of n minus 1. Very similar to arithmetic. But instead of adding or subtracting d, we're going to multiply our r value. We're multiplying by 3 to get from term to term. Don't use the x symbol for multiply when you're writing your formula because it's hard to tell if that's a variable or a multiplication sign. So that's our formula. Now we've got to find the next 3 terms. Well, since I'm already given 4 terms, the next 3 terms would be finding the 5th term, the 6th term, and the 7th term. Okay, so the 5th term, well, I would take 135 and multiply by 3. That's going to give me 405. Okay, to get the 6th term, I'm going to take the previous term, which was 405, and multiply that by 3. I get 1,215. Okay, and I take 1,215 and multiply that by 3 to get the next term, which is 3,645. Okay, numbers are very big here, but we're multiplying by 3, so it's growing really, really fast. I'm going to go grab a calculator real quick just so we can do that second problem. All right, so looking at number 2, we have negative 24, negative 12, negative 6, negative 3, ... So what's happening here? Well, if you notice, or if you notice very carefully, that you're dividing by 2, right? Negative 4 divided by 2 is negative 12. Negative 12 divided by 6 is negative 12 divided by negative 2 is negative 6. Negative 6 divided by 2 is negative 3. So I'm dividing by positive 2 each time. If I said negative there, I'm very sorry. I think I might have done that on accident. So to get from term to term, yes, I'm dividing by 2, okay? But with geometric sequences, you can't be dividing. So what are you really doing? You're really multiplying by 1/2, okay? So I'm going to use a little dot symbol for multiplying. You're multiplying by 1/2, okay? Because multiply or multiplication, let me move this over because I ran out of room. Only. Okay, we don't want to say divide. We only can use multiplication when we're talking about geometric sequences. So that's why I have that here, okay? Now I'll show it to you in the calculator as well. So if I go ahead and open my camera, okay, let me put negative 24 in the calculator. So negative 24. Let's divide this by 2, okay? That's negative 12, which is actually the next thing on our list. Also, if you're not taking notes while you're watching these videos, make sure you are. It's very important. So let's multiply this by 1/2. So we have negative 24 times, let's go ahead and multiply. Now I'm going to multiply by 1/2. So I'm going to hit alpha y equals enter. Okay, I have a fraction bar. Let's multiply this by 1/2 and see what we get. We also get negative 12. So dividing by 2 and multiplying by 1/2 gives me the same answer. Okay, well, that's going to tell me that, yes, this is geometric because I am multiplying by something constantly. I'm multiplying by, oops, I don't like this purple. This purple, okay. So yes, it's geometric. My common ratio is 1/2. So my formula here is going to be A of n equals A of n minus 1 times 1/2. Okay, now I only write the common ratio up here just so I can remember what to put at the back here. So this should be your common ratio, whatever that may be. Okay, so the next part is you're going to find the next 3 terms. So you're going to find A of 5 because you're already given the first 4 terms. So you have A of 5 is next, A of 6 next, and then A of 7. Remember, these mean the 5th, the 6th, and the 7th term. And you're like, well, how do I go from term to term? Well, first of all, we should never put decimals because sometimes those decimals repeat. So the last term, the 4th term, was negative 3. So to get the 5th term, I need to take negative 3 and multiply it by 1/2. So let's go ahead and do that. So the same thing as multiplying by 1/2 is dividing by 2. The easiest thing for me to do is to put divide by 2 in a calculator. It's way less work than multiplying by 1/2. So I'm going to put negative 3 divided by 2. That gives me a decimal, but I want to change this to a fraction. The way I do that is by clicking the math button, and then you see how it says fraction here. You're going to hit enter, and then enter again. It's going to take negative 1.5 and turn it into a fraction for you. So it's going to be negative 3 over 2. So negative 3 times 1/2 is negative 3 over 2. Okay, now I need to find the sixth term. I'm going to take my previous term, which was negative 3 over 2, and divide that by 2. Well, since negative 3 over 2 is already written here, I can really just tell my calculator that I want to divide whatever that was. You can go ahead and just click divide that by 2. So it's going to take whatever your previous answer was and divide it by 2. So I hit enter, and then it says it's negative 3/4. So a of 6 is going to be negative 3/4. To get to the next number, I'm going to divide that by 2 as well. Divide by 2, and I get negative 3/8. So that is my seventh term. Okay? All right. So that is number 2. All right, let's move on to number 3. We have negative 3, negative 1, negative 1/3, negative 1 over 9, and it continues. So how could I get from negative 3 to negative 1? Well, what divided by negative 3 gives me negative 1? And you're like, well, I don't know that. Let's put it in the calculator, see what we get. So the easiest way to do this is to just go ahead and put it in our calculator. So how do I get from negative 3 to negative 1? Let's divide those two numbers and see what we get. Negative 3 divided by negative 1. Okay, it looks like I'm dividing by 3. So let's see if that's the case. If I divide by negative 3, let's erase this actually, let's make this blue. If I divide by positive 3, negative 3 divided by 3 should give me negative 1. Negative 3 divided by 3, that gives me negative 1. Now the next number in my sequence I want is negative 1/3. So let's see if I put this in the calculator and I divide by 3 that I get negative 1/3. So let's see. Divide the previous answer by 3. I get this decimal. I want to change this to a fraction. I get negative 1/3. Is that what I have? Yep. Now let's divide that number by 3 and see what we get. So I'm going to take this number and divide this by 3. And I get negative 1 over 9. Well, it looks like my pattern is holding. I am dividing by 3. So that means that this is geometric. However, remember, we can't divide in geometric sequences. We are only allowed to multiply. So dividing by negative 3 is the same thing as multiplying by 1 over 3. Because it's multiplication only. We only multiply. Now, you don't have to write multiplication only, but you need to know that you can't put divide by 3 here. You can only put that you're multiplying by a fraction. So our formula here is a of n equals a of n minus 1 times 1 over 3. Okay? And I also need to find the next 3 terms. So I'll go ahead and write down 5th, the 6th, and the 7th. Why the 5th, the 6th, and the 7th? Because those are the next 3, right? We're already given 4. We need to write down the next 3. Give me 1 second. Okay, so now we're going to go into our calculator. Now, I already have negative 1 over 9 in my calculator, and that was the last thing that I just had. I'm going to take this number and divide it by 3. So you're allowed to divide in the calculator, you just can't give me the formula with division. So if I divide by 3 again, I'm going to get negative 1 over 27. Okay? And then to get the next term, I'm going to take negative 1 over 27 and divide that by 3. And that's going to be negative 1 over 81. Okay? I'm going to do the same thing to get to the next number. I'm going to divide by 3 again. Negative 1 over 243. So those are my next 3 terms. My number is getting smaller and smaller, and it's becoming more of like a fraction, or a bigger and bigger denominator as a fraction. So, okay, now you're like, why do you keep dividing by 3 if you keep telling us that it's only multiplication only? Again, it is way easier to type in negative 3 than to type in divide by 3 than to type multiply 1/3 every single time. So, yes, your formula needs to have multiplication in it. Yes, you are technically multiplying by 1/3. However, it is way easier to divide by 3, and you always want to choose whatever's easiest. All right, let's talk about number 4. Okay, we have 5, 10, 15, 20. I want you to think for a little bit. Do you think this is geometric? Okay, and I'm going to say no, okay? Now, what is this actually? What do you notice about what's happening? What is really happening here? You're adding 5 each time. If I'm adding 5 each time, this is technically arithmetic, right? I'm adding 5 over and over and over. Plus 5, plus 5, plus 5. So this is not geometric. It's actually arithmetic. Now this would, if I was doing an assignment what said, well, determine if it's geometric or arithmetic, then you decide, hey, this is arithmetic, then you give me the formula, then you give me the next 3 terms. However, so sorry, I need to do something really quick. Okay, so this is not geometric, but if it was arithmetic and I asked you to tell me what it's the formula in the next 3 terms, then you would. But since the directions just said if it's to just determine if it's geometric, and it's not, so we can just kind of move on from there. All right, number 5. We have -1, 5, -25, and then 125. So you're looking at this, you're like, no way this is geometric, because my signs keep changing from negative to positive to negative to positive. But if your signs are going back and forth from negative to positive and negative to positive, that's a big sign that you're probably multiplying by a negative number. So let's see. -1 times what would give me 5? Well, if I multiply -1 times -5, so if I multiply this by -5, I get +5. If I take 5 and multiply that by -5, I'm going to get -25. If I take -25 and multiply that by 5, I get 125. So I'm multiplying by negative here. So yes, this is geometric. Your common ratio is -5. Not -5, but -5. So what would your formula look like? Well, you would have a of n equals a of n minus 1, and you're going to have it multiplying by -5. So the same thing. Make sure you put that multiplication sign in there, because if you don't, then it'll just look like you're subtracting 5 each time. Okay, so you're already given the first 4 terms, so we're going to go ahead and find 5, 6, and 7. Now, this won't always be 5, 6, and 7. It just depends on what you're already given. So the 5th term, we're going to take the previous term and multiply it by -5. So if I take 125 and multiply it by -5, I'm going to get -625. Okay, if I take -625 and multiply that by, so I'm going to take this and multiply that by -5, right? So I'm taking my previous answer and multiplying that by -5. I get positive 3,125. Because I am multiplying by a negative, my signs keep flip-flopping. Then I'm going to take that number and multiply that by -5. And that's going to give me 15,625. Negative 15,625. Okay? So again, indicator that you have a negative is when your signs are flipping back and forth. Let's look at 6. We have 3, 6, 9, 15. And you're like, well, let me think in the mind of multiplication really quick. This one is multiplying by 2, right? I'm taking 3 times 2, which gives me 6. But then 6 to 9, you're not really multiplying by 2, right? Because 6 times 2 would be 12. So it's not consistent. So this is not geometric. Okay, so it's not consistent. The thing that you're moving by each time is not going to be the same thing. So, because it is not considered geometric. All right. Let's move on to number 7. So this one we don't really like because there's a lot of fractions and it freaks us out a little bit. So we have -1, -1/3, -1/9, and then -1/27. Well, -1, I'm going to go ahead and give you a hint. If you look at this, there's a -1 here. And over here I have -1, and it's being divided by what? By 3. So that's a big indicator that this might be dividing by 3. So let's check. Now this one wouldn't have a -3, right? Because your signs are all negative. They're staying negative. So if they're staying negative and not flip-flopping, your number that you're dividing or multiplying by is going to be positive. The last one right here, you are multiplying by a negative number because your signs are flip-flopping. You have positive, negative, positive, negative. This one's just staying negative, so you don't have to worry about that. So I think it's dividing by 3. So let's go and check our calculator to see what we get here. So this is my guess. So let's look. -1 divided by 3. Let's put that in the calculator. -1 divided by 3. I get a decimal. I want to change it to a fraction, so I do math, enter, enter, and I get -1/3. Check, I have -1/3. Let's see if -1/3 divided by 3 gives me -1/9. I'm going to take this number, divide it by 3. It gives me -1/9. Now let's divide this by 3 and see if we get -1/27. We do. So this is clearly dividing by -3, but remember, it's multiplication only. So what you're really doing is multiplying by 1/3 each time, right? So your formula is a of n. Sorry, I think my iPad is making a bunch of noise. A of n equals a of n minus 1 times 1/3. Okay? Let's find our next 3 terms here. Okay? Well, the 5th term would be whatever the 4th term was divided by 3. Or multiplied by 1/3, whatever you want to do in your calculator. Again, dividing by 3 is going to be a lot faster. So I'm going to take my last term, which was -1/27, divide that by 3. I get -1/81. So -1/81. I'm going to take that number, divide that by 3, and I'm going to get -1/243. Okay? I'm going to take that number and divide this by positive 3 again, and I get -1/7. Okay? So I'm getting the same sign, right? I'm continuously staying negative because my sign is not flip-flopping because I'm multiplying by a positive number. All right, our second to last problem, we are almost there. So let's see what this is doing. Well, this is 2 and then -6, 18 and then -54. So first of all, you should notice that the signs are flip-flopping, positive, negative, positive, negative. So that's a big indicator to me that I might be multiplying by a negative. So 2 times what is going to give me -3? It's going to be, not -3, 2 times what is going to give me -6? -3. So multiplying by -3 is going to give me -6. -6 times -3, I'm so sorry, let me start over. 2 times -3 is going to give me -6. -6 times -3 is going to give me a positive 18 because a negative times a negative is a positive. 18 times -3 is going to give me -54. So I'm multiplying by -3 over and over again. So yes, this is geometric. My common ratio is -3. So my formula is going to be a of n equals a of n minus 1 times -3. Okay, so let's go ahead and find our next 3 terms. We're already given the first 4. So the next 3 would be 5, 6, 7. Okay, then I would do -54 times -3. My next one is going to be positive 162. And it should be positive because my sign should be flip-flopping. So 162. Then I do 162 times -3. That's going to be -486. -486 times -3 is going to be 1,458. So I'm constantly multiplying by negative, so my signs are going to be flipping back and forth and back and forth. All right, the very last problem we have is if a of 1 equals 3, and the recursive formula is a of n equals a of n minus 1 times -4, find the next 3 terms. Well, what does a of 1 equals 3 mean? Okay, what does that even mean to me? Well, that means that that's the first term. The first term is 3. It wants you to find the next 3 terms. So I'm going to find the second term, the third term, and the fourth term. It wants me to find the next 3 of them. And how are you getting from term to term? Well, I'm multiplying by -4. So whatever you have last, you're going to multiply by -4. So 3 times -4 is going to be -12. -12 times -4 is -48. Oh, no, positive 48. My bad. 48 times -4 is -192. So your signs are flip-flopping, positive, negative, as it should because you are multiplying by a negative number. That is it for geometric sequences. Again, the hardest part is realizing what you're even multiplying by. So if you're dividing, I would definitely do the division part and then flip it and make sure it's the multiplication. So again, what you're really doing is you're just putting that number over 1. So if it's dividing by 5, you have 1 over 5 that you're multiplying by. If you're dividing by 8, you're multiplying by 1 over 8. That's probably the hardest part. Everything else, after you figure that part out, is pretty much smooth sailing because you're doing the same thing over and over again. If you have any questions, please feel free to come into tutoring and ask for help.